Welcome to the webinar. We're going to talk about Edge AI breakthroughs this morning with Steve Washburn from Convergint Technologies, Michael Liu from Chooch AI, and Amit Goel from NVIDIA. I'm Jeff Goldsmith, and I'd like to welcome you. We'll go about 30 minutes, and then we'll do Q&A. If you have questions, please ask them in the chat. And that's about it. So I'm going to pass it over to Amit. He's the Director of Product Management at NVIDIA, and we're happy to have him. Thanks.
Thanks, Jeffrey, for the introduction, and welcome everyone to this webinar today. Let me quickly share my presentation. All right, if Jeffrey, you can unmute yourself and confirm you can see, then we're good to go. All right, so, we all are hearing a lot about AI, and it's almost a foregone conclusion at this point that AI is the most powerful technology force of our time. And it's just amazing to see the journey of AI, how it started as in the big data centers where it was being run on heavy compute systems running in data centers by some of the hyperscalers, try to identify recommendations for you, tagging your photos. And from then it percolated one level deeper into cloud. Now you can get access to AI using any of the cloud services, whether you want to do natural language processing or you want to have your image detected. There are APIs available from the cloud. And what has led to further mainstream adoption of AI is deployment of AI on the edge. And this could be near edge systems or on the device, which could be robotics. And this is where the explosion of AI is happening. And the reason, again, as you can imagine, is there are going to be trillions of edge devices that will need the capabilities of AI. So for those of you who know NVIDIA for maybe as a gaming company, we are at the heart of this whole AI revolution. And NVIDIA offers the leading AI platform that spans this across the entire journey of AI, starting from products for data centers to Tesla-based products for the cloud services, and our Jetson and Drive products on the edge. And what's unique about NVIDIA and our products and the platform is it's all based on one architecture. And so what that allows is really easy development and deployment and integration. And we'll hear about a little bit more from our partners today along those lines. So let's take a step back and think about what are the challenges with AI at the edge. There are several challenges with AI, but today I want to focus a little bit on what is unique about putting AI on the edge. The first thing that's a big challenge is just the pace at which AI is evolving. The models that you developed a year ago quickly become stale because newer models come out which have much better performance, much better accuracy, and much more capabilities. So you need a platform that is not, you have to rethink about how you're building your products and deploying them, because you will have to keep changing them. You will, as you get new corner cases, as you get new model, as you get new data, the diversity and the complexity of the AI neural networks that you're using will keep evolving. So that requires a fundamental shift in the way you program things, deploy things. The second thing is when people think about AI, they start looking at, performance numbers like teraops and what is the compute capability. But, and that was okay for training, because when you're doing an AI model training, your output, your final product is the model, right? But when you're deploying an AI at the edge, when you're deploying an AI at the edge, you are essentially inference, or the AI is a small piece of it. You need to take the data coming from somewhere, you need to process it, then you need to use the AI to understand what's in that data and then act on it, right? So this, in getting the data in and then understanding it and then acting on it is a complete pipeline that needs to be accelerated. So, just thinking about accelerating your AI is not enough. You need to think about the full stack. You need to think about end to end. How am I going to solve my problem? Not how am I going to run my model, but how am I going to, save that child crossing the intersection, give him an alert, or how am I going to make sure that people are socially distancing. So you have to think about the problem as a whole and not just the AI piece of it. So that creates some challenges. And the last thing is deployment and managing at scale. Again, unlike running something in the data center or the cloud where you have an IT team or a DevOps team that is going to manage everything for you, when you're deploying it on the edge, you're talking about millions of devices. There is no one IT person that can manage your millions of devices. So you need to think about how can we leverage the same technologies that was developed for cloud and bring them to the edge so that a small DevOps team or a small AI ops team can manage these deployments at scale. So these are some of the unique challenges that people face when they're deploying AI at the edge. And to address these challenges, we created the Jetson platform at NVIDIA. And Jetson is essentially a software-defined AI computer for the edge. And it is available in different form factors. And as you can realize, there is different level of requirements for AI depending on what you want it to do. If you have a small camera at an intersection that you want to just detect the traffic flow, you just need one smaller, maybe a Jetson Nano or a TX2 to do that. But if you have a robot that's going to be driving around, looking at all 360-degree direction, having LiDARs, cameras, understanding the people behavior around it, then you need a lot more compute. And for that, we have the Jetson AGX Xavier. So these products are, again, start from the lowest level. We have the Jetson Nano, which is the entry level, allows you to do a few sensors. We have TX2 series of products, the Xavier NX, and the Jetson AGX Xavier. And as you can see, they range in price and power and performance. And the unique thing that is important here is that they all run the same software architecture. So, if you're thinking about a portfolio of products that you want to scale out from, if you're doing a video analytics application, you want a one store solution, you want a big warehouse level solution, you don't need to reinvent, you don't need to rewrite your software, you don't need to choose between different platforms. You can leverage your investment that you've made into the platform and scale it up or down depending on your application. Now, what makes it all work is the software. That's where the real magic is, right? It all starts with, it has to have a really good compute platform, which we offer with the NVIDIA GPU-based Jetson products. But what really makes it enables people to actually deploy it and use it is a software stack. So what we provide with Jetson is not just the hardware, but a complete set of tools. Not sure why this is auto forwarding. Okay, hopefully it'll stay here. Yeah, so what we provide with Jetson is a complete set of software stack, which is I'm going to keep it like this so it doesn't move forward. And this software stack includes everything that you need to build a product, right? Things from like operating system to things like production level fusing of your products to libraries for accelerating video processing, accelerating your sensor inputs, accelerating how you do your AI. And we don't stop there, right? As I mentioned earlier, the problem of AI at the edge required a full end-to-end stack. So we go one level higher, and we also create SDKs which are focused on specific verticals. And on Jetson today, we have three different SDKs. We have the DeepStream SDK, which is designed for video analytics application. It allows you to do really high performance, low latency video processing. Then we have the Isaac SDK, which provides robotics application development. And then the last piece of which brings it all together is our ecosystem partners. And with all of this together, we see AI being deployed in cities, factories, logistics applications, healthcare, and agriculture. So the third piece of our platform is our ecosystem. It is not possible to deploy AI at the edge without our ecosystem. And today we have partners, Convergint and Chooch here. So we have a lot of partners that provide ready solutions out of the box, ODMs that will provide you boxes that you can deploy anywhere. And then we have partners like Chooch who will provide you the software that needs to run on it to actually do the task that you want to do. And we have a global distribution channel. So we have close to 90 plus ecosystem partners. And this is what really enables the fast go-to-market. From the time you have an idea to actually deploy a product, you can cobble all these partners together, the solution from these partners together. They work seamlessly because we have an integrated platform, and you can go to market. And so based on this three pillars, our software, hardware, and ecosystem, we are seeing a huge adoption of AI at the edge. And it is not just one industry, it goes across several big industries, whether you're looking at industrial applications, whether you're looking at smart cities, healthcare, agriculture, logistics, retail, all these places are now deploying AI at the edge. And to talk a little bit more about how our products are being used, I would like to hand over now to Michael to share his experience with Chooch using and deploying AI at the edge. Michael, over to you.
Are you unmuted? Okay, let me share screen. Okay. Everybody hear me? Hey, good morning. So Michael Liu, and thanks so much. By way of background, I joined Chooch about 5 months ago of strategy and growth. We're a Silicon Valley-based firm and venture-backed, and we're a visual AI company. So we focus on the visual aspect of AI. Our technology detects objects, it detects actions like falling, slipping, fighting, as well as states as well. We have the unique ability to analyze images, video, infrared, X-ray, MRI, all types of geospatial data, as both on the cloud as well as on the edge. We're a member of NVIDIA Inception program. That is an AI-focused program with over 6,000 members. They help with go-to-market support and expertise. And we're also a member of the NVIDIA Metropolis program and the Clara Guardian healthcare ecosystem. The field of visual AI is very, very broad. There are thousands and thousands of companies out there focused on certain use cases, but we feel there are 3 to 4 distinct differentiators that kind of set us apart from other AI companies. As you all know, in order to generate really good models, you really need good data. And the whole process of data set collection and generation can be quite tedious. We collect images, we collect video, and imagine the process of actually annotating all the objects in video 1 frame at a time. That is a very painstaking and very, very long process. We have actually automated that process here at Chooch AI and able to generate up to 1,200 images per minute as part of the data set generation process. Our second advantage is that we develop models very, very quickly. A lot of AI companies out there often take weeks or months to kind of perfect their models to get accuracy at an acceptable level. We often deliver and base models within hours. Earlier this year, NVIDIA came to us asking on behalf of an industrial Midwestern meat processing company, can you build an AI model that would be able to efficiently and identify efficient industrial hand washing. And we end up taking stock video, and we return that base model in about 3 hours or so. Lastly, we are a horizontal AI platform, and what that means is that we are able to kind of serve needs across multiple verticals. So as a client's needs change, we can develop new models and deploy them out to the edge very rapidly on their behalf. To date, we have now developed 2 types of models. We've developed customized models for our clients. We've developed life to date about 2,400 for all different types of clients that we have. That includes clients in the healthcare field, oil and gas, retail, media, geospatial, safety and security. We have over 250,000 pre-trained classes right now and 120 base models. And we also have now created what we call pre-trained models. And these pre-trained models, or what we call public models, are ones that do not require proprietary data from clients. That data can easily be scraped from the web. Things like fire detection, things like mass detection, whether someone slips or falls, and of course, all the different pre-trained classes I mentioned earlier. What you see on the screen here is actually the Jetson Nano. Ironically, it's about 3 times bigger than it actually is in real life. It's actually about the size of a deck of cards or so, actually slightly smaller. And on this small device, we're able to fit up to 8 models and 8,000 classes, which is quite an achievement. And I'll go into a little more detail of that later on. When you start talking about the promise of edge, people keep talking about, well, what does this really mean? And what can it actually kind of do for us? Well, we know that in the cloud, it's quite easy, right? All we need to do is build the models. We can provision additional GPUs and processing capability, and we're able to kind of scale quite infinitely. But when you actually deploy to the edge, you have some constraints, right? You're talking about a smaller device, right, with a fixed amount of processing power and memory. And how can we do this without encountering some of the constraints? And those constraints often come in the form of A, accuracy suffers, B, speed suffers, and C, we can fit only a certain number of models on these devices or so. And what we've done at Chooch AI is that we've been able to architect the models in the cloud and actually export them down to the edge devices, and are able to do that without suffering any accuracy degradation. We're able to inference very, very quickly, actually around 20 milliseconds level or so in terms of object detection. And we're able to fit up to, as I mentioned earlier, about 8 models for 8,000 classes. And this has huge ramifications, right? If you think about being able to detect hard hats or vests in a warehouse, or seeing whether someone slips or falls, or determining whether a fire has broken out, you want to be able to make sure that you have enough models and compute power to effectively inference and predict them in a very, very short period of time, in this case, 20 milliseconds. The other advantages of going to the edge are, one, which is on the top of a lot of people's minds, is data privacy and protection. If you're able to export models to the edge and all the inferencing is done on the client premises, you don't have to worry about going back to a third-party cloud with sensitive data, let's say like facial data or personal or PII data as well too. Second, you're able to inference on the edge right on the client premises without any network latency, or going up and down through the cloud stack as well too. So you're gonna be able to get immediate results, which I think is also very, very powerful as well. And then third, and probably most importantly from a cost perspective, it might be okay to inference a video live into the cloud, especially in small clips, but imagine thousands of video cameras streaming simultaneously for security purposes at corporations, or monitoring a hard hat or safety conditions at millions of square feet of warehouses. This becomes computationally very, very intensive and extremely expensive. And so this is the reason why you can buy a Nano for $99 or a Xavier AGX for $899. And that's a fixed cost where all of our compute can actually be done on the edge without additional costs versus the cloud solution. I want to go into a couple of use cases here. I want to start with surgical AI. This is actually a live deployment that we have with a Fortune 500 med device company. And we're basically deploying 3 cameras and 2 NVIDIA Xavier GPUs into the operating room. The med device company plans to roll this out to 2,000 ORs across the US. And what the technology is doing is actually indexing and logging every single action that happens within the OR. ranging from when the doors open and close, to when the surgical team walks into the OR, to when the patient's wheeled in, to when drape goes up, anesthesia starts, anesthesia stops, to when the first body cavity incision is made, and then tracking all the scalpels, all the forceps, all the sponges, all the gauzes that go into the body cavity, out of the body cavity, doing needle counts, and accounting for all of that, and making sure that nothing gets left behind after the procedures are completed. This is really important, obviously, because this helps reduce risk, readmissions, repeat surgeries, and a lot of these procedures actually require an additional doctor on site to actually monitor the procedure. The ROI with this particular technology, the med device company feels that they're going to save about $1 billion. That's right, $1 billion in costs over 10 years across these 2,000 ORs. So this is a perfect example where our technology can identify objects, actions, as well as states. I want to review a use case that we've been talking to some clients about, and this is in the retail space. And there's a lot of technology out there with business intelligence, calculating things like dwell time, how interested are people in a particular product, counting number of people in a store, where they're kind of aggregating. But imagine on Monday when the Apple announces and releases their iPhone 12 in a store, and imagine having a camera trained on the table there. We could, with our technology, actually track every single demo iPhone on that table. And we can track how many times it's been picked up. We can calculate how long it's been held on average. We can determine whether it was the gold one or the silver one. We can determine a demographic. And so imagine compiling that data over a 5, 10, or 30-day period. And it turns out that the gold phone is picked up maybe 20% more of the time, held for maybe 2 minutes versus 1 minute for the silver, and of which 65% of the people who pick that up are women. So what does that do with marketing campaigns for Apple? What does that do with inventory control? What does that do with production runs, right? So there's a lot of uncaptured data here that would not be realized at a point of sale. And those of you who've actually ordered a phone, and you usually don't do it in the Apple store because they don't have your color, they don't have your size, they don't have your carrier or configuration. So this is another kind of customized use of our AI, within the retail space. I'd like to kind of close and loop back to trained models. As I mentioned earlier, trained models are ones that we can develop using commonly available data. We don't need customized data like we do in a surgery AI example. And we're starting to roll these out to customers right now. They're deployable today. One use case is industrial safety. So imagine every worker who checks into the warehouse, ensuring that he or she is wearing a hard hat, a vest, safety gloves. This hopefully will reduce workplace accidents and reduce workman's comp, which would potentially then reduce workman's comp insurance premiums or so. We also are doing a PPE compliance as well too, determining whether people are wearing masks, whether they're social distancing properly as well. And then we're also doing facial biometric access control, where people are using their face to potentially check in as well as board for flights on an opt-in basis or so. I want to close and say that we've gotten a lot of traction with these pre-trained models, and particularly within the PPE space. And this is a perfect opportunity to kind of hand it off to Steve Washburn, my colleague at Convergint, who can go into a little more detail in terms of how we actually stood up a live pilot very quickly. Thank you.
Thank you, Michael. I appreciate the opportunity to share some of our experiences and talk about what we've been working on as part of this amazing ecosystem that NVIDIA has been building. Before I talk too much about what that use case was and some of the real life examples we've been working on, I did want to share just a little bit about Convergint Technologies. Convergint is a global system integrator with over 120 locations worldwide. We have about 5,000 colleagues and annual revenue of $1.5 billion. This gives us a unique space in this industry and in this ecosystem to help our partners and to help our clients achieve the true vision and value of AI video solutions. Because we just deploy and support technology. We don't manufacture any of it. So we require and use the technology from NVIDIA and Chooch to help our clients solve very complex enterprise class IoT solutions. That's what we deliver to them. And we really do pick the best product and solution for all these applications and bring our global reach down to the local needs of that specific application that they're looking for solving. And being one of the world's largest resellers of IP video cameras, one of the leading sensor that's used to do this visual processing of data, it puts us in a great position to help our clients really achieve the benefit and value of AI. We are headquartered, we're a US-based organization. We're headquartered in Schaumburg, Illinois, and we're, which is just outside of Chicago. And we're part of the Ares Management portfolio group, a $66 billion organization. So our size, scale, and depth of knowledge are critical in the ecosystem, as both Amit and Michael have talked about, moving this technology from a lab environment into production. And that's what I'd really like to talk about right now. I know in the chat window, there's been some questions about, you know, some use cases and some potential uses. And I'd like to focus on a return to work use case that we just worked on with the NVIDIA and Chooch team. This was for one of our clients, a global-based commercial airline that has hundreds of thousands of employees, travels all over the globe. And much like many organizations, they recently had to reduce the number of staff, the number of employees coming to their facilities due to COVID. And about 45 days ago, they reached out and said, our executive team is looking for help, some ideas and some solutions as to how we can repopulate our facilities, how we can start to regain normal operations. And we need to do this very quickly because they're trying to make some of these decisions fast. So they asked us to try to deploy some of this technology in less than a week. And there was no infrastructure available. There was no cloud compute. There was no network available. There were no cameras available. So all of this had to be done in a very self-contained manner, just simply because of the privacy concerns and some of the cybersecurity concerns that I'm sure all of you can imagine. And as you know, the global transportation industry has been really hit from a financial perspective, so there was a very limited budget to accomplish this. It's these types of scenarios that most people would walk or run away from because they're so complicated, but we just love them. And it was a very fun experience for us to pull together the team of Chooch and NVIDIA to help our clients solve some of these real life business problems of identifying people that aren't wearing a mask properly, that aren't social distancing, ensuring and helping the leadership of this organization to make sure that their employees are following their policies, acting and behaving safely, and doing it in a manner that was very portable, very local, and included a lot of flexibility and payment options so that they could meet and fall within inside their budgets. I'm excited to say that after a lot of testing, a lot of hard work, in a very, very short period of time, we've been able to help that client understand the risks associated with reopening, empower their employees to engage in more safe behavior, and capture all this information and data that's being generated by the edge compute of the NVIDIA Jetson product, along with the Chooch AI inferencing engine. And I'd like to share with you all some of the information that we've been able to gather and produce, because as a part of our solution set, we also have a data visualization platform that we're able to consume all of this sensor data from all these IoT devices and represent it in a manner that provides actionable information and intelligence for our clients. The little graph that you see on the left of this slide is a snapshot of the live dashboard that we're able to produce. And this is showing non-compliance over time. So in the beginning, you'll notice that there's a lot of non-compliance occurring, and that's for a few reasons. One, the employees that are working at the location aren't following company protocol properly. And two, the model is learning. It's starting to get better. It's starting to understand what that environment it's operating with. And we're making improvements to the behavior of the employees and the performance of the model. And on that graph, as you look to the right of the graph, you'll be able to see an improvement in the amount of non-compliance, meaning there's less non-compliance over time. And this is where things get really, really interesting and exciting, is we're able to take this information that's occurring in the wild, as we like to call it, understand what that information is and improve it. And that's the image I have on to the right of this slide, that little journal entry list. Because one of the things that's also very powerful about the Chooch AI platform, the NVIDIA solution, and the team that we put together is we're able to indicate, a human is able to indicate if what's happening in the machine that's deployed on the edge, is it actually real? Is it accurate? So we've got a dashboard, we've got a live interface that a human's able to walk into and indicate, did the machine perform properly? And if the machine did not perform properly, the human can note that, which that drives confidence in the overall performance of the system, but it also gives us information to retrain, to re-educate the model, and to get better and better at the performance, which is why the graph to the left is so powerful. Because at the end of the day, we're deploying these systems, these technologies to solve real life problems, right? It's not just because the technology cool. It's not just because it's breakthrough stuff that nobody has ever done, but it's to produce real life results. And that's what we find is very exciting. And I think that's really, in closing, why people want to work with us and why people ask us to help with these very complex, challenging environments. You know, we've done this time and time again with number of partners. This is just one example, and Amit really covered it well. We really need what I call turnkey or whole solutions. We need to have partners that can provide the compute, the AI inferencing engine, but that can deploy this technology. You know, we've got 5,000 colleagues all over the world. They climb on ladders every day. They know how to aim and focus and adjust a camera. We work with very complex enterprise class solutions in some of the most challenging environments in the world. And at the end of the day, we deliver results. And that's what I think is the key part as we're looking and as you're thinking about all these various ecosystems. How can we all work together? How can we all derive and bring these video solutions forward, these advanced video solutions forward? And that's what I find is very interesting and very fun. But I could talk about this stuff forever, but I think at this point we should turn it back over to Mike or to Jeffrey and let Jeffrey start answering and opening up the Q&A session because I've seen a lot of questions come through. Jeffrey, I'll stop sharing and turn it back over to you.
Okay, I just unmuted. I think you're gonna have to. Michael and I are in the same room, so, okay. Sorry about that technical difficulty. Can everyone hear me? Yeah, okay, cool. So we've had a number of questions and I'm gonna pose those to the panel and then people can, and you guys can answer them ad hoc as you will. Let's start with the last question. Can you speak to the scalability of the solution? And I'm gonna mute myself so Michael can answer this as well. So can we speak to the scalability of the solution, gentlemen?
Can everyone hear me? It's Michael here. As far as the scalability goes, when it comes to edge devices, we actually have a dashboard that actually manages all of our edge devices. And so when we actually export models from the cloud down to the edge devices, we can do thousands literally through our dashboard and deploy those models and model updates remotely on site. As a matter of fact, the example that Steve mentioned, we're based out here on the West Coast. Steve's based in the Midwest, and the client actually was on the East Coast, and we did this all remotely. It was actually fairly straightforward.
And to add to that, we have from the product side, compute side, as I showed you earlier, we have a complete portfolio of products that can scale out the solution from tens of cameras to thousands of cameras, depending on what you need. And the software stack, as Michael mentioned, is designed for scale, right? Using container-based deployment strategies. So you can update these things, you can monitor these things is extremely important. So we do see a lot of our customers deploying these at, as I mentioned, a store level, at mall level, where you're doing hundreds of cameras. So this solution is definitely being deployed at all levels of scale.
Yeah, this is Steve. We have a similar experience where usually what happens is clients would like to test and evaluate the technology. So we start the projects out quite small typically. It usually starts in a couple of locations where they're evaluating, making sure that the business benefit is being achieved. And then once the business benefit is proven, it scales very quickly throughout the entire enterprise. And I think Michael's example in the healthcare application, where it's potentially saving them billions of dollars, is very common to the experiences that we've had as well. As once organizations start to understand, see it firsthand, and really believe in it, it starts to get adapted and deployed on a very large scale quickly. Jeffrey, back to you.
Hi. So a couple more questions. I'll just pose two at the same time, and you guys can manage to answer both at the same time. We have a question about, the question is, can you speak to any smart city or additional industrial applications? So ideas you have for smart cities or industrial applications. And also, someone is asking a very specific technical question about how many camera feeds can a Jetson Nano manage if it's got two models running. So let's just address both of those questions at the same time as you will.
This is Michael. I'll take the Nano question. The Nano is actually the first Jetson device that we actually implemented on earlier in 2020. Our preferred device right now is the higher end $900 Xavier AGX. It's actually much more powerful, as you saw on Amit's earlier screen. With the Nano, we can handle one stream right now. But the AGX, we can handle at least 5 streams simultaneously. And we're talking about streams that are RTSP compliant in terms of their protocol, 30 frames per second, 1080p or higher.
And to add to what Michael said, we do see some customers deploying few streams. The question of number of streams depends on a lot of variables. What resolution do you want to detect? How accurate do you want your models to be? Are you okay with false positives or negatives? And I think Chooch has a variety of models that you can choose from, right? If you are doing a mission extremely important operation like a surgical room, you want to use your best models, right? You want to have the highest quality model. You want to process the highest resolution data. So you want to see the smallest level of detail. And that's where you need an Xavier class product. If you're just trying to see, people coming in, going out, you could use something that's a smaller model, and you could run a more number of streams in Nano. So it completely depends on the application that you're trying to address on the number of streams. The second question was about industrial applications and smart city applications. So there are a lot of smart city applications, from things like smart lighting, where people are putting these cameras and deciding when do they even need to turn on the light. If there's nobody on the road, why do you want to spend that energy resource running the light? You want to optimize your traffic. You want to understand how do I change the signals so that my traffic can move more smoothly? Or identifying areas of possible accidents and how you can change your traffic flow so that there are fewer accidents. And the smart cities area, there's again lots of applications like this. Now with opening back America, there are lots of cities need the ability to monitor if people are following social distancing or not, if they're following the CDC guidelines or not. So that's extending into smart city. On the industry side, we see applications in predictive maintenance, understanding what's happening with the machine. When even before it fails, you want to be able to have a technician go there and repair it. Quality assurance is a big one, right? It's an extremely hard task, very manual process, and very tedious process for people to actually inspect small device parts and make sure that there is no ding on your iPhone, there's no scratch on it. So you can use AI-based, quality assurance and defect detection for that in industrial application. And there are more. I can go on all day, but anything you want to add, Steve, Michael?
Yeah, I was going to say, I mean, really, your imagination is the limit, and the breakthrough that's occurring in the technology today is a couple of things, and we've talked about it repeatedly. One, it's the edge-based AI computing technology that NVIDIA is bringing to the table. So before, all of this compute would be very expensive. It would be very large, probably in a data center type of environment, which was not very practical because video streams, as many of you know, are very large from a bandwidth perspective, consume a lot of, very hard to move around from a network. And then another breakthrough that's been occurring, and why we love working with the NVIDIA and Chooch team, is really Chooch's ability to have all these publicly pre-trained models at our disposal, but then to adjust those models on basically on an on-demand basis and quickly retrain a model or train a model to do something new and unique. So whatever you can think about, if your eye can see it, and if it can be something that happens repetitively, meaning it happens more than once or twice, and it provides you business value, we are confident as a system integrator that we can take some of this edge compute technology with some of this amazing AI technology from Chooch, deploy it in your environment, and produce some real life, some results. And like Amit said, I mean, it's really, the sky's the limit on what you think you can do and accomplish. It does take I'm going to say a little bit of creativity, a little bit of willingness to experiment on things. Some things are straightforward, like the mass detection scenario that we talked about. Some things people have done over and over again, but sometimes there are some unique things that people look for. Don't be scared about trying those things, because we've done those projects, we've had those successes, and it really kind of adds a lot of benefit and value to the organizations from my perspective.
So a few more questions. There was a question about whether we have ruggedized our installs, and another question about, oh, let's see here, too many questions to manage all at the same time. And another question about how fast is the market growing for this? So have we ruggedized? How fast is the market growing? What do you think?
I'm going to wait for a second. Regarding the ruggedized solution, we actually do work with the US government, and they do require a ruggedized solution. So we have a couple partners that we work with to help ruggedize for the various different harsh operating conditions or so. And I imagine that if you're going to stand up some of these technologies outdoors, where there's sun and rain, you know, I think that's also kind of important to know that that can be kind of weatherproofed or so. I think we talked to 2 or 3 providers. As far as installation goes, I mean, that's probably more in Convergent's court, right? We are a software company at Chooch, and we kind of stop at the JSON response and maybe provide some basic analytics. But then in terms of additional analytics or installation last mile, that would fall in Convergent's court.
Yeah, Michael. Just to kind of jump off on that, we're seeing this technology deployed pretty much all over the world. So it could be an oil and gas rig, very harsh, very, I'll say inhospitable environment, to even office environments. And one of the technologies that we understand or envision as an enabler is 5G technology. And I alluded that to a little bit on the use case I shared with. I mean, we're able to deploy these edge-based processing technologies, load these inference engines right at the very point of the video, and then transmit that video back in very small data packets and bursts, really anywhere. And that's pretty amazing when you think about it, because if you have a camera someplace and you add a 5G or a different type of, you know, cellular connection to it, you can really put that technology basically anywhere in the world, run the computer algorithm against it, the computer vision capability against it, provide the data that you need, and then visualize that data from the comfort of your desk, right? And that to me, I think is what gets very exciting. And it's going to spread that and increase the adaptation of the technology as it continues to, you know, gain more acceptance and knowledge in the industry, in the world, that this is possible.
Okay, a couple more questions. A question about, will edge computing require any changes to an organization's operating model? And another question about integrated devices, cameras with NVIDIA inside. And we do know about, there are some partners that we're working with that have NVIDIA devices inside of cameras, and changes to organizations. Do you guys want to address that? I mean, things are going to change, obviously. Amit?
I can, yeah. So on the cameras with Jetson devices inside them, yeah, we are seeing a bunch of them now coming out with Jetson Nano. In the past, you know, the TX2 and the Xavier were too powerful for one camera, so nobody would put them. It was mostly, you know, bringing multiple feeds into a single system and running it. But with the Nano, we have the right form factor. So there are several companies that are building cameras with an embedded Jetson product in there, so you can run it. It's all on the one box. Talking about changes, as I mentioned, it requires you know, deploying AI at the edge for, and it has to do with not just necessarily edge computing, but it has to do with the AI itself, right? Deploying AI requires some changes to the way the companies operate. First thing, as you saw in the graph that Convergint shows, you have to be prepared that things will learn. You have to be agile. You need to be monitoring your initial data, and you need to keep updating it, right? So you need to plan for that this is not a, you know, one-time done thing and it's over. If you're deploying AI on the edge, and if you really want to maximize your investment, you need to be prepared to have a team that can monitor things, that can update things, and make your solution better over time. So although it's running all on the edge, but you know, you are ultimately improving the value that the end customer is getting. So you may want to think about how that business model works. But apart from that, yeah, I think you know, deploying computing on the edge is enabling a lot of people to go beyond their traditional solution where they were limited to things that were connected or had a data center or a cloud connectivity.
Yeah, I would jump off of what Amit just said. I think what we've seen is a few things. One, these systems and these technologies, you do have to understand you're going to need to support them. And support is not only on a hardware perspective, making sure the device is working, because once they start producing the benefit and value, they become so mission critical to what you're doing. So you need to be prepared for that. But you know, I think Amit hit it right on the head. You have to be prepared for learning and growing and adapting with it, because you know, this is going to change a lot of the ways you think, a lot of the ways you execute and do things, and that's going to change over time, because you know, we live in an ever-changing world. So it's really maybe not so much like a departmental change per se, more of just an awareness change in how you want to engage with technology and how you want to use technology, and really a flexibility, and you know, it's going to learn, it's going to adapt, and that's going to force your organization to maybe act or behave a little bit differently. And so change management, I would say, becomes a really important piece as well.
So I have we're almost coming up on the hour. We have about 8 minutes left. So there's a question about AI training, about whether we can, let me look at Fred's question again. Yes, exactly. If you guys can see in the Q&A, it's quite a good question. Seems like a video feed data stream has high signal noise ratio. How it's about, the question is about industrial tool preventive maintenance. We've actually addressed this with a customer. How would you guys go about, we can start with Michael, beginning this process of, we have an industrial tool preventative maintenance problem, and we have a video stream and we want to train for that. How would we solve this problem as an ecosystem? Was that a clear?
Yeah, that's fine. Can you? So going back to a point I made earlier about data set collection and generation, as I said earlier, we take in both images as well as video, and we've developed a technology to actually take the video, ingest it, and actually track the particular objects or anomalies of interest. So in this particular use case, if there was an anomaly that you want to be able to show and look at from different angles through video in all different states, we would need to basically take that video, draw the bounding boxes and identify the anomalies that we're interested in, and actually then run the video through and generate all those training images from that. Now, our data is always going to be as good as the quality of the video feed itself. So if it's poorly lit, if it's a little bit blurry, that data is not going to be as useful or helpful. If the resolution is clearer, if the lighting conditions are better, and we can actually get really, really good images there, then the quality of our data set is going to be much higher, and we'll be able to much more efficiently train for that. And we can do that for anything. So imagine if you're trying to identify a car, and you want to make sure that it's a particular brand of car, you would need to be able to figure out every single angle, right? Every single color, every single lighting condition, right? And that's thousands and thousands of images. But once they're all uploaded into the data set and then sent to the model for training, we have pretty much have then taken care of every single use case. So often they say that, you know, good models are dependent upon, you know, huge, vast amounts of good data. And that's this case here. Video does supply a lot of that data, and we're able to kind of really shorten the length of time it takes to actually extract the data from videos, and hence develop the models more quickly.
So I'm going to unmute. Okay. I think this is going to be the last question because we're really out of time now. A question about collective approach to cybersecurity malware with regards to software updates. So we have an ecosystem where Chooch is able to update models on remote devices from our dashboard. And so how do we prevent cybersecurity issues, malware to any of these software updates? Guys, do you have any answers to that? I'm just a marketing guy, so I'm not going to go there. But it's a legit question: cybersecurity around our deployments. Any?
This is Steve. I'll take a high-level marketing type of approach to it. It is a very important piece. Honestly, some of the things that we see frequently, one, we do see the question about video quality we have to address, which Michael did a nice job of responding to. One of the other questions we typically run into is privacy, which we've talked just briefly on, which we could have a whole nother discussion on, privacy and the ethical use of AI. And then probably one of the third biggest questions we run into is the cybersecurity question. And what that revolves around from our perspective is really having the appropriate compute solution that is, you know, we do full boot level encryption, full encryption on transport of the data streams that might be occurring. And then we also include some pretty robust cybersecurity management and hygiene type of tools that exist and kind of work all together. You know, I'm not going to do the technology answer justice, but it is kind of one of the three key check the box questions that we need to work on, that we need to address. And it usually becomes a highly collaborative process because these technologies are being deployed in a customer's environment. So that customer usually has some expectations around what they feel are the appropriate ways to be executing and delivering this. So it becomes a shared security responsibility approach where we take best practices on the deployment, support of technology, interfacing that with inside the organization's typical cybersecurity expectations and meeting those requirements. It's very doable, very achievable, but it is something that we have to think about and make sure we execute and implement properly.
And yeah, I can add a little bit on what we do on the platform side. Given that these products that we're building are designed for critical applications, we take security very seriously. And within our platform, there are lots of things that we do in our hardware and software stack. As Steve was saying, we provide all the tools that you want to do for secure boot to make sure that the root of trust and the trust chain is maintained. Also on the hardware level, there is a lot of things that are built into if you look at the latest generation of Jetson product, we are always increasing more and more security features built into the hardware, so that even if somebody, because these devices are in the open, people can get physical access to it. So we are thinking about what can people with bad intentions do with it, glitch detection and whatnot. So there's a lot of monitors and on the hardware itself that can detect any of these activities, and also on the software stack, we are providing all the tools that you need, whether it's fuses, whether it's encryption. We have dedicated hardware accelerator blocks so that you can encrypt everything without sacrificing your performance. So all these things are available on the platform to make sure that you are deploying this in a secure and efficient way.
Okay, everyone. Well, thank you for, there are still a few more open questions, but we're at the top of the hour and I don't want to keep everyone beyond 10 a.m. Pacific time. If you have additional questions, you can contact any of us. Amit is at NVIDIA, of course. Michael and I are at Chooch AI. My email, well, I'm not going to, you can use the contact form on our website, and we'll get right back to you with any of these additional questions. And of course, Steve is at Convergint. So we'll be sending out a recording of this webinar. And thank you all very much for attending. It's been a great turnout, and appreciate the panelists. Thank you, Michael. Thank you, Amit. Thank you, Steve. And we will speak again soon. Thank you very much, everyone.